What shape is this curve? The first thing we can notice is that because of the squares, we are adding two positive numbers to give 1. That means that each of those numbers must be less than 1. And so if x squared over 4 squared is less than 1, x squared must be less than 16, mod x must be less than or equal to, we could have 0, 4. And the same way, mod y must be less than or equal to 3. If y is 0, x could be plus or minus 4, so we're allowed points on the axis at plus and minus 4. And if x is 0, y is plus 3 or minus 3. And apart from that, we can't go outside minus 4 to 4 or outside minus 3 to 3. We end up contained within that box. We know that the graph passes through the points 4, 3, minus 4, and minus 3 on the axis. And let's see what happens as we move our point. As x decreases, y increases. And going around here, because of the squares, it's symmetrical, we're going to get the same pattern. And if we look at the bottom half, there we have an ellipse. In the same way, we could show that x squared over 3 squared plus y squared over 2 squared will be a Cartesian equation of an ellipse, and x squared over 3 squared says that it goes through at minus 3 and 3 on the x-axis, y squared over 2 squared at 2 and minus 2 on the y-axis. Which takes us nicely into the general equation for an ellipse. X squared over a squared through minus a and plus a, y squared over b squared through plus b and minus b. So far, we've looked at the Cartesian equation for an ellipse. Let's look now at the parametric equations. If we look at these equations, then we have x is a cos t, y is b sine t. When t is 0, cos 0 is 1, sine 0 is 0. So when t is 0, we're at a 0. So when t is 0, we're there. When t is pi by 2, we're at y equals b, x equals 0. When t equals pi, when t equals 3 pi by 2, and back to t equals 0 or 2 pi. And at an angle of t, we are at a cos t, b sine t. Let's tie up the parametric equations and the Cartesian ones. What happens if we want to eliminate t? We have that x over a is cos t, and that y over b is sine t. And we know that cos squared t plus sine squared t is 1, which gives us that x squared over a squared plus y squared over b squared equals 1. So the parametric equation and the Cartesian equation do describe the same curve.